Hello everyone, very good evening. Welcome to Unified Study all of you. So here today I am here to discuss with you the questions. Here you are getting always confused, that is the deadlock free condition. Means deadlock free condition, this numerical always students are getting confused that ma'am how to solve, what is the value, what is the maximum value of n, ma'am we are not getting. And sometimes it is also happening that you are trying to solve the question with some formulas, you are trying to memorize some formulas, and after that actually you will be able to solve some question with the formulas, but after that you will be stuck. Like this question, here is a question, if you are trying to apply the formulas, always you are not able to do it because your concept is not clear. And that's why I am here to discuss with you this type of question. It is one question, it is the next question, it is also another question, this type of question, it is also another question. How to solve this type of question, that's why today's class we will do this. So definitely I hope you will learn this total video and you will watch this total class, you will be there with me completely, so that your understanding will be clear, and ultimately after doing it your confirm marks, you will get a confirm marks in operating system. So it is an important topic of operating system, always questions are coming from deadlock, right? So are you interested or not? Yes, I hope so. So what is the maximum value of n to get a deadlock free system? Sometimes it is asking the maximum value of n like number of process. What is the number of maximum process will be there? What is the requirement of maximum resources? That is also they are asking. Even also sometimes the question are asking like that, ki the process is also given, resource is also given, total number of process is also given, total number of resource is also given. They are asking what is the maximum need of each process. Just like this question here, this question is asking that maximum k instances. So what is the maximum need of each process? How to solve this type of question? So these are the three types of question what you can get in exam hall, and I will tell you the very easy way, I will discuss with you, and after doing it, it will be super easy for you. So why you are waiting? Please like this video, share this with your friends and tell your friend to join the session. I am waiting for everyone, but till now I can see how many students are there. I can see Deepak is here. Please let me know who are here. Let me know who are here. I can see Deepak and user. Comment in the chat box. I hope I am visible, audible, everything is clear, right? Yes or no? Let me know in the comment section so that I can understand, okay, something is there or not, who are here, at least let me know. Yes, Siddhisha is also here. Dakshani is also here. Okay, very good. Very good. Okay, so let's see. First of all, you have to understand what is deadlock. When the deadlock is happening, what is the condition of deadlock? When the deadlock will happen? Deadlock is a condition like that some argument is going on you and your friend. There is an argument going on. Maybe you and your spouse. Always the argument is going on between them. Your father and mother. Everywhere means between husband and wife there are always some argument is going on in each and every home, right? And after that sometimes also it is happening, both are telling I will not eat, I don't want to eat, I am not feeling hungry, I don't want to eat. They want to skip their dinner, either the wife or the husband. So it is the situation, here is the wife and here is husband. right? First you will eat, then I will eat, first you will eat, then I will eat. Now it is a problem. Both are depending on each other. Now they are creating a cycle between them. First you eat, then I will eat, first you eat, then I will eat. So whenever this type of cycle is arising, it is called deadlock. No one is agree, no one is want to agree with that. Okay, do it fast, no. And this type of situation will arise also when in operating system there are the resources, because in operating system they are sharing the resources, right? So some processes are there, those who are sharing the resources. Like how they are sharing the resources? You have only one pen, okay. Now to write down it, you need a pen and paper. You want to take a notes, but only one pen you have. You need a pen and you need a paper also, then only you can write it down. Now the situation is there are three friends. This is friend 1, friend 2 and friend 3. Everyone need one paper and one pen. Everyone need one paper and one pen, one paper and one pen. This is the condition, so that they can write something, they can take the notes. Now if the situation is like that, there is only one pen available. In this situation everyone have the paper, but only one pen available, right? In this situation what they will do? The three friends will share that pen, right? So how it will be done? Maybe that one pen, it will be maybe someone took that pen, his work is done. After that he released that pen, and after that next one took that pen, he wrote it down, and after that next one take that pen and he wrote it down. It will be a agreement, okay, it is a mutual agreement. There is only one pen, so that we have to share. This is the same thing happening in the operating system also. They are sharing resources, okay, they are sharing resources. Now it can be a situation like that, when there was a requirement of one pen only. Maybe in some situation it's required, some situation, think like that, anywhere its situation is like that, it's required 3 pen. Everyone required 3 pen, maybe 3 color pen is required, one red color, one green color and one blue color pen required everyone, right? So now in this situation how they will do it? And here it's a situation like that, what is my maximum need? I have to think like that in this situation, that when there are two types of problems are coming. One is the same resource type, and multiple number of instances, like a printer. Printer is the resource, and in the printer there are maybe 5 printer are available, and there are 5 processes also, P1, P2, P3, P4, P5. 5 processes are there. Every process is taking one printer, it is also taking one printer, it is also taking one printer, it is also taking one printer. Okay. So 1, 2, 3, 4, 5. 5 printers are there. Just wait 1 minute, someone is calling. Wait 1 minute. Okay, yes, hi, sorry for the disturbance, I'm sorry. Yes, good evening all of you. Deepak, Manjula, Sunitha, Narathan, Jasmine, Rijana, Bibin, everyone. Okay, Mayuri, Divya. Yes, so here it was a situation when I have 5 printer, 5 process are sharing 5 printer, everyone is getting 1 printer, so no problem at that time. Now, if the situation is that every process, each and every process required 3 printer at a time, the maximum requirement is every process required 3 printer. This is the maximum requirement. The maximum requirement of each and every process is 3 printer, okay. But I have only 5 printer. Can I share it? I have only 5 printer. Can I share it to the process? Can I share it? Is it possible? And is it possible that anyone can execute in this situation? I am giving 1, 1, 1, 1, 1. Any one is not able to execute. Is it or not? At a time I need 3 printer, then only I can execute my whatever my process. But I have only 5 printer, I am giving everyone 1, 1, 1, 1, 1. Is it possible any one is executing at that time? No one will be execute at that time. Everyone is waiting for more 2. Every process is waiting for more 2, but that is not available to me. That is not available to me, so it is a deadlock. This condition is called deadlock. When everyone is waiting, no one is able to execute, now it's a deadlock, right? Because now if in this situation, when it is possible, there is 2 way possible. What is the 2 way? First way is that maybe I want to remove some process. I am trying to remove some process, right? If I am removing 3 processes and only 2 processes are remaining here, this is one situation. I will remove 3 processes and only 2 process is here. Now for this 2 process I allowed 2 printer. Now till now in my hand 3 printer are available. Now can I distribute this 3 printer? Yes. Now I can add here 2 and I can add here 1. Now easily this process can execute now, right? And after the execution, now more process, more printer will be available to me, right? It will release more 3 printer here, and out of this 3 printer I can give it to 1, and now easily they can execute. So this is one method where you can preempt the processes, means I will delete that processes so that I can overcome from the deadlock. Some of the processes are creating problem, that's why I am trying to take the resources forcefully. One thing is that I can take the resource forcefully, or another thing is that I will delete that processes so that I can come out from the deadlock situation. So it is one way. What is the another way? Is there any other way? Here I arbitrarily delete some process. Now here the question is that what can be the maximum number of process I can execute in this situation? That is our target. Unnecessarily I will not delete multiple process. I will try to delete minimum number of process, and my target will be to execute maximum number of process with the available resource, right? That should be my maximum target. Clear? So how to do it? Here is a very easy concept. How to do it? So I will tell another scenario. After that I am coming to the concept. Another scenario is that what can be we can do. There was 5 process P1, P2, P3, P4 and P5. 5 processes are there. and I have 5 printer also. Now in this situation everyone got 1. Now everyone need extra 2. Now in this situation if I add more extra 2 printer, so in my availability now extra 2 printer is available. Now can I give it this extra 2 to any one of them? Can I give it this extra 2 to any one of them so that they can execute? Yes or no? Yes. In this situation can I put it? Can I do it? Means I can increase the number of resources also. That is also a situation. I can increase the resources also. But the problem is there, question will tell you there is fixed number of process and there is fixed number of resource. So you cannot change the number of process also, you cannot change the resource also. Now in this situation what to do? How to solve it? That is our target. So that's why always our target will be to see the maximum need of each process. That should be our target. And if you are able to identify the maximum need of each process, so in this situation there was P1, P2, P3, P4 and P5, 5 processes are there. Maximum need was 3, 3, 3, 3, 3. This was the maximum need. Now in this situation actually if you are thinking how many resources are required at a time, 3 plus 3 plus 3 means actually 15 resources are required at a time, so that I can distribute among them, right? So that is the means this is the worst case. This is when I have 15 resources I will give it to distribute to everyone. So I cannot buy that much resources because it will take more money. Now our target will be what will be the minimum, how I will manage with the minimum resource. How to manage with the minimum resource? What is the minimum number of resources required so that there will be no deadlock? That is our target. Got it? What is the minimum number of resource required so that there will be no deadlock? Now how to do it? Here we will do that. Our maximum need of each process was 3. We will do the max need minus 1. Max need minus 1, that is 3 minus 1, 2. And I will try to do like that everyone have 2 resources, right? Now in this situation if everyone have 2 resources, now everyone need 1 extra. If I can provide this 1 extra, then anyone can execute and after that it will release and others can execute. So now what is allocation? There I have allocated already 5 into 2, 10 resources. These 10 resources I have allocated. Now if I add extra 1 with them, this extra 1 I will add with this. Now it will be done. After doing this it will release 3 resources. Now here is this 3 available. And now I can give it to this one extra, this one extra, this one extra. They will also done. After that they will release these all and finally P1 will be done. So there will be no deadlock and everyone can execute now, right? So without buying 15 resources, I can buy only 11 resources so that I can overcome from the deadlock situation. This is the one question when they are asking the minimum number of resource required so that the system will be deadlock free. And here just in this way you have to do the answer. Is it clear? Is it clear to everyone? Just check the maximum need of each process, then do maximum need minus 1. This is called the worst case scenario. When I have maximum need minus 1, I need only extra 1. If I get extra 1, then I can execute. Everyone is waiting for extra 1. And if I can manage that extra 1 and I can provide it to anyone, they will be deadlock free. Got it? So here what will be the answer? Answer will be 11. Clear? Is it clear? Yes. Another thing is that here in this situation only, now we will do what is the maximum. Here I am adding some extra pages. I am adding some extra pages here. Another situation is that where they will ask you what is the maximum number of process. Here we did the minimum number of resources because always our target is cost. It should be more effective. So here we did the minimum number of resource required. Now the next question will be asked that what is the maximum number of process possible to get a deadlock free situation. In this question only, if I am telling what is the maximum number of process possible. Now if I am telling here the resource will be given, I am taking that my resource was 5 resources in my hand. In my hand there was 5 resources, and in this situation everyone maximum demand was, what is the maximum need of each process? Maximum need of each process was 3. Now in this situation we have to understand what will be the number of process, maximum number of process. Same way we will do the worst case. What is the worst case? That is 3 minus 1, 2. So if I am giving process 1 2 resources, process 2 2 resources. Now in this situation everyone need 1 extra and I already allocated 4. I have 5 resources. So this 1 extra will be available now in my hand. So this one I can provide to 1 and this one I can, after that it will release and after that P1 will be done. So that's why here what will be the answer of maximum process? It will be 2. Can I do 3 resource? Can I do 3 process? No, I cannot, because here P1, P2, P3, if I am adding 3 resource, 2, 2, 2, they require 6, it is not possible. So always our target will be whatever resource is given, do it the number of resource minus 1. That only I can distribute, because 1 in my hand I have to do, right? Or otherwise you can do the worst case and distribute the worst cases. After that check 1 have to be there in my hand, extra 1, at least extra 1 have to be there in my hand. So in this situation what will be the maximum process? That is 2 only. Clear? This is another type of question where they are asking what is the maximum number of process you can execute, where the maximum need of each process will be given and the number of resource will be given. So what are the given data here? Given data is the number of resources, total number of resources, and the maximum need of each process. Got it? Then they will ask what will be the maximum number of process. I hope it is clear. Clear? Yes or no? Tell me. I hope this is clear to everyone. Yes? Yes. Right. Now the next question is this. Now solve this question. Now the next question is, here they will give you the number of processes also, number of resources also. They will ask you the maximum, what can be the maximum need, so that there will be deadlock free. So same question, if I am taking here that number of processes may be 2 and number of resources is 5. So what can be the maximum need so that it will be a deadlock free situation? How to do it? How to do that? Same way, you will see that my number of resources is 5. So to deadlock free, I have to keep 1 in my hand. So I will do 5 minus 1, 4. Now this 4 I have to distribute in the number of processes, that is 4 by 2. So what can be the maximum need? Maximum need can be 2, not more than that. Is it? Is it maximum need is 2? No. Here this, after this 2, it is your worst case, plus 1. So maximum need can be 3. Maximum need can be 3 here. So that process 1, process 2, in the worst case I will distribute 2 and here extra 1 will be there in that time. That one I can provide everywhere. So that's why maximum need will be 3. These are the 3 types of question. Clear? Is it clear? I hope you can do it. Now any type of question, whatever. I am showing you the question quickly. So do this question. Do this question. What will be the answer? Here, consider a system 3 process that share 4 instances and the same resource type. Each process can request a maximum k instances. Resource instances can be requested and released only at a time. The largest value of k. What will be the largest value of k? Total number of resources are given 4 and total number of process is given 3. Now they asked you what will be the maximum need. What will be the maximum need? Do it. You can do, right? Yes. I hope you all can do it. So what is the answer? Yes. Yes, definitely. Here also I will do. In my hand I required 1 extra. So that extra I will keep it in my mind. Now I have 3 and 3 processes. So 3 by 3 I can put 1 to every one. So process 1, process 2, process 3 I will put 1 to every one. Then this extra 1 is there. So that's why it will be 2. So my answer will be 2. Right. So that's why answer is 2. Now the next question. A computer has 6 tape drive with n processes computing with them. Each process may need 2 drives. What is the maximum value of n? To deadlock free operation. Here it's given that number of resource 6 and each process need 2 tape drive. So max need is also given 2. Now they are asking what is the number of process. What will be the number of process here? Do it. Yes, what will be the number of process here? How many process can be there? Maximum value. What will be the maximum value of n? What will be the maximum value of n? Same way, I will do the worst case. Yes, I will do the worst case. What is the worst case? Maximum need minus 1, that is 1 is the worst case. Now in the resource also here, now I will distribute P1, P2, P3, P4, P5, 1, 1, 1, 1, 1. After that I need extra 1, that extra 1 so that I can allocate. So definitely there will be 5 process, right? Yes, good. Now the next one. Here this is another one. Suppose a system has 12 instances, some resources, n with n process computing. Each process required 4 instance, maximum value of n for that where never deadlock will occur. How to do it? How to do it? Number of resource given 12 and maximum need give 4, maximum need also given, and here it is asking what will be the number of process again. What will be the number of process again? These are the previous year's question, guys. What will be the number of process? Maximum number of process. Answer quickly. What will be the answer? Same way think, yes, same way think, the maximum need minus 1, worst case is 4 minus 1, that is 3. Now this resource, how I can distribute? If I am taking P1, P2, P3, 3, 3, 3, already I distribute. Can I take it to P4? Can I give it to P4? No, I cannot give it, because after that 12 will be used. So I cannot give it, because if I am giving this 3, then it is not possible, it will be deadlock again. It will be deadlock again, not 4. You cannot provide it. Here clear your concept. It cannot be 4, because if I am giving all 3, 3, 3, then 12 will be utilized. How I can give that extra 1? At least extra 1 have to be there, at least. But here that extra 3 will be there, that is okay, but I cannot execute 4 instances. I have to execute 3 instances only, because the worst case is very important. Okay. Here the answer will be 3. Always remember about the worst case. You have to think about the worst case, that is the max need minus 1. In that worst case only, when I am giving it to everyone, after that only the deadlock can be arise. So always distribute the worst case. After distributing the worst case, it should be there something in your hand. Minimum 1 resource have to be there in your hand. If you are distributing to 4 resources, then there will be no resource available, right? So that's why maximum 3 resource you can execute. Clear? Is it clear? If I am giving it to 4 resources, after that nothing will be available to me. That's why I cannot do it. Okay, 3 process. Yes. Now the next question is here. Consider a system M resource same type. These resources are shared by P1, P2, P3, which have the peak demand of 2, 5, 7 resources respectively. It is different resources availability. Now for what value of M there will be deadlock will not occurred? Now tell me. Here processes are given, maximum need are different, then the number of number of resources you have to do. What will be the answer for this? And this is the next question, this is the last question for ultimate understanding. What will be the answer? Yes, answers are coming, very good. P1, P2, P3. Here the maximum need is 2, 5 and 7. What will be the worst case? I will do the worst case, minus 1. 1, 4 and 6. So 1 plus 4 plus 6, that is coming 11. Now 11 is there. I need more extra 1 so that there will be no deadlock. So, minimum will be 2, 12. But in the option 12 is not there. So, more closest answer I will choose the 13. Actually, with the 12 only I can do it. But in the option 12 is not there. So, I will choose the 13. 11 is the worst case. Now, I need extra 1. With the worst case, after the worst case, I need a extra 1 so that any one can execute. After that, they will release, then next one will execute. After that, next one will execute. Right. So, the minimum will be actually 12. But in the option 12 is not there. So, I will choose the 13. And that is why answer will be 13. Got it? I hope now total deadlock is clear, right? Good evening, ma'am. Unify study. My name is Priyanka. Great. Thank you so much. Now you are calling me with ma'am Unify study. That's really great. Yes, it was my dream that okay, everyone will call me as Unify study. Thank you so much, Raju. In every video I am not telling my name also. Thank you. Yes, Raju, welcome. Very good. I hope you maybe you are from South India. So try to refer your friends. Try to share the link to your friends. Okay, so that they can also get the benefit. I know that there are lots of Hindi resources available. मुझे भी हिंदी बोलना आता है लेकिन नहीं मैं बोलती हूँ क्योंकि मुझे पता है I know that there are lots of requirement for the South Indian student, those who don't know Hindi. They need the resources to learn because ultimately they have to crack the exam. That's why I am trying to help you. Although my English is not that much good, but I am trying to help you so that at least you can learn. Right? Clear? I hope after this session, deadlock will be super easy to everyone. And it's a request to all of you. Try to share this link to all of your friends. Try to share this link, okay, so that they can also get the benefit. Chalo. Bye everyone. See you again next class. So please like, share and subscribe to the channel and share this video as much as possible. Okay. Chalo. Bye. Here Anant, Sirisha, Raju. Yes, Raju, Narathan and Mumtaz, Rijana, Dakshani, Mayuri, Ishani, Deepak, Shirisha, Ishani, Narathan. Yes, all of you. Bye. Bye. Bye everyone. Sneha is also here. Divya is here. Everyone. Thank you so much for joining the session and thanks for motivating me. Really, you all are motivating me. Thank you. Bye.